Hello, I am Professor N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology, and in this video we will calculate current in the 10 ohm resistance by using Thevenin's theorem. This is a bit a typical problem because here is the load resistance RL, which is 10 ohm. It is in between. But the steps will be the common, same. First step is remove the load resistance and redraw the same circuit. Step number 1. We will remove the load resistance and we will draw the same circuit. Its figure will be something like this. We will remove the load resistance and we will redraw the same figure. Here its figure is something like this. This is negative. This will be the positive. This is B and here is the A terminal. And remaining figure is the same. This will be plus minus and here. This is 3 volt plus minus 2 ohm. This is 5 ohm. Here is 2 volt. This is 3 ohm. Here it is 2 ohm and this will be the 10 volt. What we have done, this is A and this will be B and we have removed this resistance. That's it. Remaining figure is the same. That is as it is. Now here is the negative and this will be the positive. Now in this case we are interested to calculate the VTH. That is the step number 2. Step number 2. To calculate this voltage, we have to travel from the B towards A. Maybe by using this path or maybe by using this path. Use any path, potential will be the same. Means we need to know the current in this path or current in this path to calculate its value of the VTH. Now here is the single loop. Now we will apply the KVL to this loop and we will calculate its current I. We will calculate current I. Calculate its current I. Now here it will be plus, this is minus, plus, minus, plus, minus. Depending on the polarity, we will mark the terminals. This is the positive terminal of the battery, negative terminal of the battery, and so on. If we are applying the KVL and we are starting from this point into the loop in the upward direction, negative to positive, which is a plus 10 volt, then positive to negative, which is minus 3 into its resistance, which is I, then positive to negative, which is minus 5I, then minus 2 into I, then positive to negative minus, it is 3, then positive to negative, which is minus 5 into its current I. Then we are coming back positive to negative, which is minus 2 into I, which is equal to 0. We are not selecting this path because it is open circuit. It is not a closed path, or this 2 volt battery is not the part of the closed path. That's why this will be the equation. Now here in this case, this is constant potential. This is constant potential. That's it. That is 10 minus 3, 7. This 7 is equal to, we are taking the I common, 3 plus 5 plus 2 plus it is 5 plus 2. This I is equal to 7 divided by addition of all these. Here we have 3 plus 5 plus 2 plus 5 plus 2, which is equal to 70. 7 divided by 17. This is 7 divided by 17, which is equal to 0.41 amperes. 0.41 amperes. Now here in this case, 0.41 amperes is the current I. Then we will find out the value of the VTH, which is equal to modulus. We are traveling from B towards A. Use any path. I will use this path because in this path we have the less calculations. We are traveling in this direction, negative to positive plus. Its potential is the 2. Then positive to negative, which is minus 2 into its current. Its current is a 0.41. The current is the same for all elements because it is a single loop. The negative to positive, which is a plus, is voltage is 10. Then positive to negative, it is minus 3 into its current is 0.41. Then there is no element which is the A point, which is very same as this is VTH. This is 2 minus 2 into 0.41. 2 into 0.41, which is 0.82. This is 0.82 plus 10 minus 3 into 0.41, which is 1.23. This is 1.23, which is equal to, here I will do these calculations. This is 2 minus 0.82, then plus 10, then minus 1.23, which is equal to 9.95. Means here 9.95 volt is the value of the VTH. Now if we know the value of the VTH, then we can find out the value of the RTH. We can find out the value of the RTH. Third step. I will use here third step. Now here we will redraw the same circuit, but all sources are replaced by the respective internal resistances as well as the load resistance will be removed. Load resistance is already removed here. But here, what is the difficulty? Whenever we have the terminals in between, in that particular case, the calculations will become difficult. Calculations will become difficult. That's why we will extend the terminals outside and we will redraw the same figure. This here, this 3 ohm first as it is. This is battery replaced by the internal resistance, which is 0. Which is 0. Here. Then 2 ohm as it is, which I am drawing. Here this is 3 ohm as it is. Here is 2 ohm as it is. Then here I will complete the downside part. This is B. I am taking B outside. This is B, I am taking outside, and this voltage source is replaced by the 0 resistance. Then here will be the 5 ohm, then I will come down, this is again 5 ohm, here this is 5 ohm. Then here I will complete the first upper part. The A terminal here, this is A, this is A. Here will be the A, I will extend outside, this is A. This 5 ohm, which is here, 5 ohm. This 2 ohm as it is, this is 2 ohm. And 3 volt will be replaced by its internal resistance again, which is 0. This figure will be something like this. Figure will be something like this. Now here in such cases, the calculations of the resistances will become somewhat difficult, especially for the beginners. Now what I will give the simple trick. Assume this whole circuit is made up of the elastic. Now here, putting the one finger at A, second at B, stretch this figure, stretch, and then try to draw the extended version of the figure. Here is A. If we are stretching this figure, assuming it is made up of the elastic, its next figure will be something like this. Something like this. And here, it will be something like this. Here will be the B terminal. This is B. This 3 ohm will be here. This 2 ohm will be here. This 5 ohm will be here. Here is 2 ohm. Here is 5 ohm. Now we have the simple figure now. Series and parallel. Now here in this case, 3 and 2 are in series. I will extend this figure in this way. Here 1. This is second. This will be B terminal. Here it is A terminal. This will be the B. 3 plus 2, 5 ohm. And here 5 plus 2, 7. 7 plus 5, that is 12. 12 ohm. Now RTH is equal to, these two resistances are parallel. That is 12 into 5 divided by this 12 plus 5, which is equal to 60 divided by 17. 60 divided by 17, which is equal to 3.529, means 3.53. 3.53 ohm is the value of the RTH. That is Thevenin's equivalent resistance. And if we know the value of the VTH and RTH, then I will use this portion. Then complicated network is replaced by the Thevenin's equivalent network, which is something like this. RTH we have calculated, which is here 3.53. This is 3.53, and VTH is 9.95. Here 3.53, and this is 9.95 volt. Then reconnect the load which is removed in the first step itself, 10 ohm. Now here we can calculate this load current now using the formula IL is equal to VTH, which is 9.95 divided by RTH plus RL. 3.53 plus 10. 3.53 plus 10, which is equal to, in this case, 9.95 divided by 13.53. Here its answer is coming to be 0.735. This 0.735 amperes is the current flowing through the load resistance by using Thevenin's theorem. And these are some tricks and techniques to be used while solving the sums based on the Thevenin's theorem. That's all for this particular problem. Thank you.